Today we're going to look at multiplying polynomials, and you may notice that this isn't really a polynomial out here, it's just a monomial. So this is what we were working on last class, and we were just saying if I have parentheses and I can't combine the things that are in the parentheses, all I have to do is distributive property, which means I'm going to take this -2 and I'm going to multiply in all three places. Kind of like a distribution center. All of your stuff is in one location and you've got to spread it out to all the stores on your route. So I'd use this -2x and I multiply the numbers, add the exponents, multiply the numbers, add the exponents. Again, those are just ones. But then when I do -2x times -5, I only have numbers to combine here. So I'm going to make sure that I combine the numbers and leave the x like it was. I can't do anything else in the problem because all of these variables have a different exponent. So I'm done. I can't do anything else with this problem. What's different about this is I have a group of things trying to multiply to a group of things. This is a binomial, 2 pieces, times a binomial, 2 more pieces. So if I'm trying to do this with the concept that I used over here, where I'm doing distributive property, I actually have to do distributive property twice. I've got to do distributive property to move this -2 to both terms. I have to do distributive property to get this x delivered to both terms. But to help you understand physically what's going on here, I'm just going to turn this into a rectangle, just so you can see it better. I want you to have a visual understanding of what's going on here. I'm going to make a 2x2 table. 2 because I have a binomial here, so I'm going to have x and -2 as my 2 dimensions on that side. And then I have another binomial here, 3x and 4, so I'm going to put both of those labels up onto the top. Now notice I had no way to show that this was a subtraction, so I put that subtraction sign as a negative to go with my 2. Now notice I have 4 little squares in here. All I have to do now is get my 4 products. I'm going to end up doing x times 3x squared. That would be if I multiplied those two. I'm going to have x times 4x. It was positive. Now, that would be like multiplying these two. Notice that was just distributive property. All I really did was distribute the x to both of these numbers. If I look at my chart here, I still haven't done -2 times 3x. So I'll do that. That would be like taking this -2 and multiplying it to 3x. And then the last box I have is -2 times 4. That would be doing my last. So if I make the picture, if I make this rows and columns, 2 rows, 2 columns, because I had a binomial and a binomial, I can see how I'm supposed to get 4 products. The same way I would see that if I distributed the x and then distributed the -2. So I've done that process, I have my 4 products, but I can't stop the problem because I have some like terms. I need to put my like terms together. So remember, descending order, I'm going to start with my highest exponent, 3x squared, but I have 2 terms in it which are to x to the first power. So I have to combine those through addition. -6x plus 4x, -2x. And then I have this -8, which is all by itself, and I have an answer now. I was able to multiply these 2 binomials together. How did I know it was multiplication? Because there was no symbol in between these parentheses, so I knew it was multiplication. And that's why I was able to use distributive property or just set up this rectangle and solve it out. So now I have one step harder here. I'm going to take this problem out and I'm going to make it a super problem. What if I had a binomial times a trinomial? So what if I had 2 numbers on the outside the one on the left, and then I had 3 on the inside. Now I have a binomial times a trinomial. So if I'm doing my same visual picture, my visual picture has 2 numbers. I'm going to call them terms, 2x and a positive 3. But this one has 3 terms in it, so it's a trinomial. And each column is going to get its own label. So first term, second term, third term, I just put it out in this nice little sheet. Now that I have it, I can see I'm doing 6 multiplications. I'm doing 2x times 3x squared. Remember, adding the exponents when I multiply. I'm doing 2 times negative 8. And adding the exponents because I'm multiplying. 2 times negative 2. There's nothing to influence this x to the first. It just stays x to the first. Yeah, we don't really need that in our final answer. I'm just leaving it there for concept. That would be like distributive property. I've delivered to all 3 of the locations that were in my back trinomial. Now I'm going to my 3 and I'm multiplying 3 times 3x squared, 9x squared. 3 times negative 8 is negative 24, x to the 1. 3 times negative 2, negative 6. It just so happens in this particular example, because my original polynomials were written in descending order, I got this really nice descending pattern. If I go through and look at all 6 of these products now, I have to actually combine the like terms. So if I look and say there's only 1x third, I'll write it. I have 2 terms that are x squared. So I need to do 9 plus negative 16 to get my negative 7x squared. I have a negative 4x, but I also have a negative 24x. So I have to combine those to get negative 28x. And then I have the negative 6, which is standalone. So no matter how big these numbers get, really all I'm doing is distributive property over and over again. I distributed the 2x to all 3 terms. That's what's shown in this top row. I then distributed the 3 to all 3 terms. That's what I'm showing in the bottom. And all 6 of those calculations were products, were multiplication. Once I was done with multiplication, I didn't have parentheses anymore because I took care of those with the distributive property. Now that I don't have parentheses, I can combine like terms. I can look for like exponents and start putting them together. Notice I started with x to the third because that was my highest power. And I always in math want to be listing in descending order unless the directions state otherwise. And that's how we multiply polynomials.